Okay, this is going to be a quick review of the geometry shapes that I think you should know about. Okay, start with really simple. If you have a rectangle, the it, area is length times width, and the perimeter is 2x plus 2y. Two of these sides and two of those sides. Next up, triangles. On a triangle, the area is 1/2 base times the height. And the height is straight up and down, and the base is here. And that's true even if the triangle is off to a side. This would be the height, and this would still be the base if the triangle goes to there. And the perimeter is just the sum of the sides. Side 1 plus side 2 plus side 3. Circles. This is the one a lot of students tend to forget. And so I'm going to try to help you reason out what the answer should be for the area and the perimeter called the circumference. Okay, so I believe you all know that's called the radius. And so is that. And that square is a radius square. And its area, if this is r and this is r, it's r times r, or r squared. Hence we call the second power a square, because it's area of a square. When you take something by times itself, you're finding the area of a square of those dimensions. Anyway, moving on. How many of these squares does it take to cover the circle? And most people say of those squares it takes 4. But if I draw them, I didn't quite get to the center here, the 4 squares would be too much. If I take the stuff that's hanging out, stick it in here, the stuff that's hanging out there might fill up this, and the stuff that's hanging out might fill that, and it's more like 3 of those radius squares would cover the circle. Well, it turns out it's just a little bit more than 3. It's 3.14, or pi of those radius squares cover a circle. Now, as for the circumference, if we take the diameter all the way across the circle, take that, and if that was a piece of wire and I took it off there and bent it around, it would probably end up somewhere about there. And so then if I started there with it again, I'd probably end up somewhere about there. And if I started again, I'd probably end up somewhere around there. And so I hope you can see that it would take a little over 3, 3.14 diameters to go around a circle. And a diameter is 2 times the radius, so sometimes it's called 2 pi r. 2 radiuses times pi. There's a circle. Next, related to a circle is a sphere. Now, before I do a sphere, I'm going to do a cylinder. And just like a rectangular box, I want to know what the volume of the box is. First thing you want to do is count how many cubes. Say we're doing inch cubes and they happen to look like this. How many cubes fit this way? And it might be 3 or 4. And then how many cubes fit across? That might be 5. And so the number of cubes that fit on the bottom of the box, in this case, would be 15, or length times width. And then you're going to have that many in each layer for however many layers up it is. Let's say it was 4 layers up, so then I would have the height, or I'd have 3 times 4 times 5, or length times width times height, is the volume of a box. Well, the same principle holds for doing a cylinder. A cylinder, you count how many cubes will fit on the bottom, and that depends on the area. And the area is a circle, pi r squared. So the number of cubes that fit in here on the bottom is equal to pi r squared. And then you have that many going all the way up, so the volume of a cylinder is pi r squared times how many layers high it is. Okay, now if I make a cylinder that fits over a hemisphere, that would be bigger than the hemisphere's volume, the top half volume. So let's just look at that now. The radius is r. In this case, the height would also be r. So this can that would hold the hemisphere would have a volume of pi r squared times r, or pi r cubed. But that's too much. Now, what if I made a cone? So let's talk about cones. Anytime we have a shape like a cylinder going to a point, or a pyramid going to a point, anytime I have a shape going to point, it's 1/3 the volume of the box it would come in. So the box it comes in is length times width times height. Length times width times the height, straight up and down. So that's the volume of a pyramid. The volume of a cone would be 1/3 of the volume of the can, so it's 1/3 pi r squared h. So if I put a cone inside the hemisphere, its volume would be 1/3 pi r cubed. The can is 3/3, or 1. The hemisphere is halfway between, 2/3 pi r cubed. And so if I do a whole sphere, I have to double that, and it becomes 4 pi r cubed. Now, what's the surface area of a sphere? Well, if you figure out the area of the circle right here, that would be just pi r squared. If you take that circle and reshape it to cover the sphere, it turns out to be enough to cover half of the hemisphere. So to cover the whole sphere, it's 1, 2, 3, 4. 4 pi r squared is the surface area of a sphere. Now, if you're doing the surface area of a cylinder, you'd have a circle and a circle, one on bottom and one on top, so you have 2 pi r squared, 2 circles, plus the sides. Now, if you take a cylinder, imagine a tin can, you cut the lid off and cut the bottom out, slice it up the side, it's going to be the same height all the way through, and it's going to have a length around that rectangle of the same length as going around a circle, and going around the circle is 2 pi r, or pi d, and its height there, so it's 2 pi r times h. And that's the surface area, the total surface area of a cylinder. if you're interested. This one's not one that normally we ask students to remember. All of these formulas I've given here already are ones you should be familiar with and have already in your head. If you don't know them, you should get a note card, get them on your note card someplace. Okay, the surface area of a cone, well, clearly the surface area has a circle for the bottom, but it also has this shape that's kind of like a triangle spun around. And so the triangle is 1/2 the base. Well, the base would be the perimeter of this circle, which is 2 pi r, times the height. Only this time it's not this height, but it's the length of this side. So that's the L. And the 2 and the half cancel, and so the surface area of a cone is pi RL. That's all the sides, all the way around, plus the bottom, the base. Okay,